In this section, we're essentially forming a bridge between what we have known about fractions for some time and what we're going to start doing when we see x show up in some of our fractions when we look ahead. So when we start out in this first section, it says we're reducing fractions and we're factoring things out to make 1. And whenever we use the word cancel, really what we're talking about is taking something divided by itself to make 1, and whenever you multiply something by 1, it goes away. It cancels, but the word cancel can be a little deceiving, so we're going to use the phrase making ones. Now, if we look at this fraction here, 96 over 48, you might have an idea of how you would reduce that fraction. But what we're going to do is we're going to actually start factoring the top. And I know that 96 is even, so I can divide that by 2. And if I do that, I'm going to get 2 times 48. And I know that I could keep factoring 48 all the way down to a bunch of very small numbers. But what I noticed is that I have a 48 on top and bottom. So since I broke down that 96, I'll cross that out. But now I have a 48 on top and bottom. And that 48 divided by 48, that is essentially forming a 1. So when I cancel those two out, when I cross them out, I'm leaving it with just 1 on top and 1 on bottom. And so, if I'm reducing my fraction, I have 2 times 1 on top, which is just 2. I have just 1 on bottom, which is just 1. And I have reduced my fraction to the number 2. Another example over here, if we have 16 over 44, I know that 16 can be written as 4 times 4. I'll just cross it out there. And I could keep going, but for now I'm just going to stop. I also on the bottom know that 44 is 4 times 11. So I broke it down, I factored that into 4 times 11. And now I see that I have a 4 on top and a 4 on bottom. So those two are going to cancel out or make a 1 together, leaving me with a 4 on top and an 11 on bottom. And I know that 11 doesn't factor any further, so there's nothing else I can do, and my fraction is going to be 4 over 11. And the last one here I'm going to let you do on your own. Next thing is multiplying fractions and then reducing them. Now, when a lot of people multiply fractions, they think cross multiply, and even you can see how it seems like there's arrows pointing towards, when you do the multiplication symbol, towards doing this in a cross-way form. But that is wrong. Do not do that. Do not cross multiply. When we multiply fractions, we're multiplying straight across. We're going to multiply the 4 times the 3 up on top, and we're going to get 12. And that's going to be our numerator. When we multiply fractions, we multiply our denominators straight across. 9 times 6 is going to be 54. So when we multiply these two fractions, this is what we're doing. This is what we get. We get this 12 over 54. Now, we can reduce this number. So if I were to say, let's do what we did above, and let's break this down into 2 times 6. And on the bottom, I know that 54 breaks down to 9 times 6. Cross those out, and we're left with our factors. I see the 6 and the 6 are going to cancel or make 1 together, because 6 divided by 6 is 1. And I'm left with a 2 over a 9. So my fraction reduces to 2 over 9. Now that's one way to do multiplication, but an even easier way to multiply fractions is if we can simplify, if we can reduce on the way when the numbers are still small. 12 and 54 are big numbers, but we could have actually made some reductions earlier. So let's look at this same problem and say, how might we do this in an easier way? Well, for one, I see that I have a 4 over a 6. 4 over a 6. And I know that 4 breaks down to 2 times 2. 6 breaks down to 2 times 3. So I factor both of those. And then I see the 2 and the 2 are going to cancel out. They're going to make 1. Since I know that everything is being multiplied on the top and everything is being multiplied on the bottom, I essentially can make one big fraction where everything is being multiplied together, allowing me to say, hey, I see a 3 over here and a 3 over here, and I can cancel both of those out. I can make 1 out of both of those. So now on top I see I have a 1 and a 2, which is just 2, and on the bottom I have a 9 and a 1, which is 9. So I have 2 over 9. And since 2 does not factor any farther, there's nothing we can do to reduce that fraction anymore. So I'm going to let you do these other ones on your own here, but you're essentially looking top to bottom, and you're allowed to go diagonal because of the fact that it is just one big fraction with multiplication on top and multiplication on bottom. That's why you are allowed to say, hey, I can reduce, break this 4 down, and break this 8 down so that I'm left with a 1 up here and a 2 down here. You're allowed to do that because of the fact that it becomes one big fraction when you multiply. And so I'll let you finish those two on your own. Next one, dividing fractions and reducing at the same time, is the same as multiplication. Division is the inverse of multiplication. If you think of 4 divided by 2, what you are really saying is 4 times 1/2, or 1/2 of 4. That's the same as 4 divided by 2. All you do is you flip the second number and turn it into a multiplication problem. You take the reciprocal. So now let's do something that's a little bit less intuitive. We have 4/5 divided by 4/9. What we are really saying is 4/5 times 9/4. We are saying 4/5 times 9/4. So we are taking the reciprocal and then multiplying. We are flipping the second fraction, multiplying. The first one stays exactly as it is. We don't touch that. But we flip the second one. And then we can do what we did above. We can say, hey, it's a multiplication problem. Let's make one giant fraction, multiply the tops, multiply the bottoms, and while everything is already partially factored for us, let's simplify. 4 and 4 break down to 1, and then the 9 and 5, the 5 doesn't factor, so we're left with 9 on top, and 5 times 1 is 5 on the bottom. So the first step we did was we flipped the fraction. The second thing, and turned it into a multiplication problem. Then we turned it into one big fraction with multiplication on top and bottom. Let's do the same thing down here. We have 3/6 divided by 1/2, which is the same as saying times 2/1. We flip that second one, make it a multiplication problem. And when we multiply two fractions, we're really multiplying the top and the bottom separately. And I see that 6 here, and I see, okay, I can break a 6 down into 3 times 2. So let's factor that down to 3 times 2. And on top I have a 3 and a 3, so those break down to 1. I have a 2 and a 2, so those break down to 1. So I'm left with 1 times 1 on top. I'm left with 1 times 1 times 1 on bottom. And that worked out nicely, just down to a 1. Last two problems over on the right are for you to do on your own. And then the final section here, we're adding and subtracting fractions, and when we add or subtract, we always have to start with common denominators. In this first one, we have a common denominator. When we add these, we don't say, oh, 7 plus 6 is 13, 9 plus 9 is 18. We do not do that, although you may be tempted to. We have to make sure we have a common denominator, common baseline. In this case, they're both 9 as our denominator, so that's good. That means that our denominator for our answer is also going to be 9. And then we go ahead and add our numerators just as we expected. So 7 plus 6 does equal 13, so our answer is 13/9. Now, in middle school, you may be very used to the idea of, oh, improper fractions, I want to convert that into a mixed number, 1 and 4/9. When you're doing a lot of things in algebra, improper fractions are going to be a lot easier to work with and a lot more common to see. So leaving something as 13/9 is actually the more common way to leave your answer when you're in algebra. So just be aware that this is actually normal. So that would be a good answer. I'm going to skip down to this example. I'm going to let you do this one above on your own. 3/5 minus 3/6. To do 3/5 minus 3/6, we need to get ourselves a common denominator. But before we even do that, because we're doing subtraction, and I do not like subtraction, I'm going to turn it into an addition problem. Because all subtraction is just adding a negative number. So I got rid of that subtraction sign, made it a plus sign, and I put a negative up here on my entire numerator of my second fraction. I didn't put it in the denominator, I didn't put it in the first fraction, I only put it in the numerator of the second fraction. And that'll be important later on when we start seeing a bunch of things up there. But for now, I took that 3 and made that negative. Now if we're looking for a common denominator here, we're saying what are numbers that both 5 and 6 can go into? What is the smallest number they both go into? Though it's not essential that we pick the smallest number, it can save us some work later on. Another thing that can save us work later on is if we do a little bit of reducing first. You might notice that 3 over 6 is actually not in simplest form. That 3 over 6 could be reduced, and we can say, oh, well, 6 breaks down to 3 and 2. So the 3's are going to cancel each other out and just become 1's, leaving this fraction as negative 1/2. So really we have 3/5 plus negative 1/2. And by reducing it early on, we've saved ourselves a step later. Now a common number that both of these could go into is 10. So I'm saying, how can I make tenths out of both of these? And the easiest way when both things are reduced is often just to say, oh, okay, 5 times 2 is 10, so if I'm going to take this fraction, which is fifths, I'm going to multiply both the top and bottom by 2. Now I can make 10 on the bottom. And the second one is has 2 in the denominator, so I'll multiply top and bottom by 5. The important thing is that whenever you multiply one of these fractions to change its form, you multiply it by the same thing on top and bottom, so you're really just multiplying by another form of 1. And if we go ahead and work this out, we have 2 times 3 over 2 times 5, so we have 6 over 10, plus we have negative 5 over 10, and that leaves us with 6 minus 5 on top, which is just 1, and then our 10s stay across on the bottom because it's just addition of fractions. So 1/10 is the answer to that question. And you take the same approach as you work through all of these. If you can reduce things first, it's going to be a lot easier. Then you get yourself a common denominator and go ahead and carry out your addition or subtraction. Good luck!